This is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which I will go through everything you need to know for the upcoming test on linear relations. Let's start from the very beginning. So we're looking at the relationship between two variables, and we usually call those x and y. Variables just means that their values can change. They don't occupy the same value all the time. Of course, x and y can change from question to question, but say the number 2 is not a variable because it always means the same thing. So x and y can stand for just about anything. X could be the time, y could be the distance or an amount of money or whatever. Whatever x and y stand for, we analyze their relationship mathematically the same way. So what does it mean if the relationship between x and y is linear? Well, let's look at a table of values. You're probably familiar with this, and we can use this to compare values. So I'm just going to chuck in some random values for x and y. So here, each time x is increasing by 1, going up by 1, y is doing the same thing each time. It's going up by 2, and that's what makes a relationship linear. Each time x goes up by 1, y goes up or down by the same amount. The amount by which it goes up or down is called the gradient. Because it's going up by 2 each time, it has a constant gradient. The amount it goes up or down by doesn't change, and therefore the relationship is linear. If I change this value, so it was 6 here, then it would have gone up by 8 the first time, then it would have gone down by 4. It wouldn't be doing the same thing each time. That would not be a linear relationship. But because I didn't do that, because y is going up by 2 each time x goes up by 1, the relationship between them is linear. The reason we call it a linear relationship is because if I was to graph these relationships and show their relationship visually, I could plot all these as points, and these points would all lie in a straight line. That's where we get the name linear. So you probably know how to plot points already, but let's just go through nice and quick. So we have our Cartesian plane. X is the horizontal axis, y the vertical axis. So if I wanted to plot this point that's circled in green, it has an x value and a y value. So I would just go across to x is -1, and I go to y is -2, and I just put a dot there. So note when I'm writing the coordinates of a point, so if I want to write the coordinates of this green point, it goes in brackets, x value always goes first, comma, y value. So this is the point -1, -2. So I could plot the next point, x is 0, y is 0. Just plot that there, easy as. The next point is x is 1, y is 2. So if I extend my axes there, I could plot a third point. And all of these points lie in the same line. Of course, during the test, your graphs will be a lot more accurate and a lot more beautiful. So this is the line that visually displays the relationship between x and y. You can see it is a straight line. That is why the relationship is linear. So it has a constant gradient. Each time x increases by 1, each time we go across 1, we're going up by 2. That's what makes it a linear relationship. So we're often interested in the equation of lines. So the equation is a rule that tells us how do we find the y value if we know the x value. So in this case, the equation of the line is y equals 2x plus 0. I can write it in the form y equals mx plus b. That's another way to show that the relationship between x and y is linear. That you can write the relationship as y equals something times x plus something. So this number that goes in front of x is also the gradient. And as you can see here, the gradient of our line was 2, which we figured out up here. B is the y-intercept. this number is where the graph hits the y-axis. And you can see that the graph intersects the y-axis, the vertical axis, at 0. That's why this number here was 0. So if you can write the rule that links x and y in the form y equals mx plus b, then the relationship between x and y is linear. Then if you graph it, it will be a straight line. So when you're given the equation, it's pretty easy to determine whether or not a point will lie on that line. So for example, I might want to know, does the point, say, 1835 lie on this line? So if I kept going all the way up to x is 18, would the y value here be 35? So remember, when we're given a point, the first number is the x value, the second's the y value. If I want to check whether this point lies on the line, I simply substitute it into the equation. So my equation is y equals 2x, or 2x plus 0. So if I change the x, I'm going to rub out the x and change it to 18. So I get 2 times 18. And I'm going to change the y value to 35. Then I get 35 equals 2 times 18 plus 0. This is clearly not a true statement. 35 is not 2 times 18. That's an untrue statement. Therefore, the answer is no. 1835 will not lie on this line. So I also want you to know that if I give you any 2 points in the Cartesian plane, say this point and this point, there is one and only one line that will go through those 2 points. In this case, the only line that would go through those 2 points has equation y equals 2x plus 0, or y equals 2x. One and only one line. And that line will go through all the points where the y-coordinate is double the x-coordinate. So that's what the line is, just an infinite set of points. Now, if I gave you just one point, there are infinitely many lines that will go through it. So let's say I plot this point here. So this point I've just plotted in yellow would be the point 0, 2. There are infinitely many lines that go through this point. I could have one across here, one going down like that. So many lines, infinitely many. So if I wanted to give the equation of a line that went through 0, 2, that's pretty easy. It's just saying what's a possible way I get the y value from the x value. So I could just take the x value and add 2. Y equals x plus 2 will go through that point, because 2 does equal 0 plus 2. I could have the equation y equals 2x plus 2. That will also go through that point. I could have the equation y equals minus a third x plus 2. That will also go through that point, because if I substitute x equals 0 and y equals 2, I get a true statement. So you need 2 points to characterize a line. And from that, we can get the equation. And I'll show that a little later in this video. Now what we're going to do is we're going to look at 2 points. And just before we find their equation, we're going to look at finding distance, midpoint, and gradient of the line segment. So I've got 2 points here. There is one and only one line that will go through them. There is also one and only one line segment that will join them. So a line segment, unlike a line, has a start and an end. It does not go forever. So if you like, this will be the starting point, this will be the ending point. So because it doesn't go forever, we can calculate its distance. We can also calculate its midpoint. I'll also show you how to calculate the gradient. So firstly, let's start at midpoint. So I'm saying if I plotted these 2 points and joined them up, what would be the point on the line segment that is halfway between them? Now we want to be able to do this without plotting the points, because that takes a while. So that's actually pretty easy. So midpoint, our answer will be a point. It will have an x value that goes here and a y value that goes here, in brackets, because it's a point. So you find the x coordinate by simply adding up the two x values and dividing by 2. And similarly, you find the y-coordinate of the point by adding the y-coordinates and dividing by 2. So the midpoint of this particular line segment, we just take the two x values. Remember, x is always listed first. x1 just means x-coordinate of the first point, and so on. So x1 plus x2, add the two x values, divide by 2. Do the same for the y values, add them up and divide by 2. And the answer you should get is 5.5 and minus 7.5. So the midpoint doesn't have to have whole numbers. You can have an x-coordinate of 5.5 or 5.4 or whatever. So that's the midpoint. So the distance is actually using Pythagoras. You find out, like if you start here, how far you've gone across, how far you've gone up, and the distance is the hypotenuse of the right-angled triangle. So the distance formula is square root of a squared plus b squared. It's the difference between the x value squared plus the difference between the y value squared. Okay, so in this case, the distance would be the square root of 8 minus 3 squared. Make sure you're okay with negatives. So this would be minus 10 minus, but because this is a minus 5, it'll be another one. Minus 10 minus 5 squared. So you can put that straight in your calculator into two decimal places. You should get about 7.07. We're not concerned whether it's centimeters or whatever. So that's midpoint and distance. Please pause and copy down if you need this, because I'm going to rub this out and go through gradient. So the gradient has the same meaning as it did before. It's saying each time we go across by 1, each time x increases by 1, how much is y increasing or decreasing? So to figure this out, when we have 2 points, we can use the 2-point formula. So the gradient, by definition, is rise over run. The rise is just the difference in y value, how far you've gone up. And the run is the difference in x values, how far you've gone across. Please make sure you get this right, because a lot of people make the mistake of putting the x's on top. But no, it's the y's that go on top, because it's rise over run. So it's y2 minus y1. Again, we've got to be careful with negatives. Over x2 minus x1. So in this case, it would be minus 5 over 5, which is minus 1. So this line segment would have a gradient of negative 1. So if the gradient's negative, that means the line leans left. If the gradient is positive, it means the line or the line segment leans right. So in this case, the line segment would lean to the left because I have a negative gradient. What this negative 1 means is that if I were to join up these 2 points, each time you go across 1, you go down 1. Each time x increases by 1, y decreases by 1. So now we're going to have a very quick tutorial on graphing. So there's a few methods I'll quickly show you for graphing. So the first one was the gradient intercept method, when the equations of the form y equals mx plus b. Any line can be written in this form. Remember, m, the number in front of x, is the gradient, and b, the number by itself, is the y-intercept. Note, this is only true. The number in front of x is the gradient, and the other number is the y-intercept. This is only true if it's y equals something. So this method is pretty logical. You just use these two things to find 2 points. So what you do is you mark the y-intercept. Secondly, you use the gradient to find a second point. And the third thing is you just join up the 2 points. Because remember what I said? If you have 2 points, there's one and only one line that goes through them. So basically, we're just finding 2 points that lie on the line, and we join them up. So for example, let's say I had the equation y equals 3x minus 1. So this is in the form y equals blah, blah, blah. So the number in front of x is the gradient. So the gradient here is 3, or 3 over 1. And then the number by itself, which is not 1, is minus 1 here. That's the y-intercept. So what we do is we go to our Cartesian plane. Of course, x is horizontal, y is vertical. So the first thing we do is mark the y-intercept. So the y-intercept is minus 1, and I mark it. Now the gradient is 3 over 1. So the bottom number tells you how far you go to the right. Always go to the right just to avoid confusion. The top number tells you how far you go up or down. If it's positive, you go up. If it's negative, you go down. So if the gradient is 3 over 1, what that actually means is that you will go across 1 to the right. So I'll do that here, 1 to the right, and up 3. 1, 2, 3. Your second point is now here. Now you've got the 2 points, you just join them up, and you should put arrows on the end. So this is the line y equals 3x minus 1 I showed you with the gradient intercept method. Okay, the other methods that we used, if it's not written in this form, it might be written like something times x plus something times y equals something. So this is easiest if we use the xy intercept method. So its process is exactly what the name suggests. So what you do is you find the x-intercept. You do that by letting y equal 0. Then you find the y-intercept by letting x equal 0. Again, we're finding 2 points and just joining them up. So it's easiest to use when it's not of the form y equals mx plus b. So let's say we'll try 3y minus 2x is equal to 6. So we're going to follow the process. So firstly, I find the x-intercept by letting y equal 0. So if I change y to 0, what I'm going to do is write my original equation, 3y minus 2x equals 6. Now, if y equals 0, this first part's just going to disappear. Because 3 times 0 is 0. And I'm just left with minus 2x equals 6. X is 6 divided by minus 2, which is negative 3. Do very similarly for the second part. I'm going to take my equation. This time, I'm going to let x equal 0 to find the y-intercept. So the minus belongs to the x, so it goes as well. So I'm left with 3y equals 6, y equals 2. So this line has x-intercept of minus 3, y-intercept of 2. So I can go to my Cartesian plane. I plot the y-intercept at 2. I plot my x-intercept at minus 3. Put dots there. And then I just join them up. And again, I need lines. Okay, I should label the line too. So that's how you graph using the XY intercept method. So there are a couple of special cases where you don't use either method. And these are lines parallel to axes. So if you have the equation y equals a number, no x's in it, that line is going to be perfectly horizontal or parallel to the x-axis. Or if it's x equals a number, it's going to be perfectly vertical and it's parallel to the y-axis. So I know that that's not really intuitive, is it? That y equals a number is parallel to the x-axis, x equals a number is parallel to the y-axis, but that's the way it is. So let's look at graphing something like y equals 3. So this is going to be a perfectly horizontal line with y-intercept of 3. So we'll just go to our Cartesian plane again, label the x and y. So I go y equals 1, 2, 3, which is here, and I just draw a horizontal line through that point. So this here in blue is the line y equals 3. So let's say I wanted to graph the line x equals minus 1. So that's going to be a perfectly vertical line, and it's going to go through minus 1, perfectly vertical. Okay, so what I hope you notice here is this red line, which I didn't do a great job of, I apologize, but this red line here, its x-coordinate is always -1. The y-coordinate changes, you know, it's 3 here, it's 1 here, but the x-coordinate's always -1. Similarly, in the blue line, the y-coordinate is always 3, even though the x value will keep changing. So they're a special case if it's just y equals a number without x's or x equals a number without y's. So that's graphing. And we just need to know, the last thing we need to go through is finding the equation of lines. Oh, and I suppose I better do some word problems as well. So let's look at finding the equation of a line. So I told you before that if we have a linear relationship, if we have a line, it can be written in the form y equals mx plus b. So all we need to do is find m, which is the gradient, find b, and then we just write our equation. It'll be y equals mx plus b. All right, let's look at some examples. So what would the equation be of a line with gradient 5 and y-intercept 2? Well, the first two steps are already done for us. We're told the gradient's 5, we're told the y-intercept is 2, so the equation of the line would just be y equals gradient times x plus y-intercept. That's the final answer. Easy as. So let's find the equation of the line in this diagram. Again, sorry about the wonky line. It's just a bit hard on my iPad. So we're going to follow these steps. We're going to find m, find b, and then we have our equation. So remember, gradient equals rise over run. So start at the leftmost point here. To get to this second point, I've gone across 2 to the right. So 2 goes on the bottom. And I've gone down 4 from y equals 4 to 0. So I put a 4 because I went down 4, the negative because I went down. If I went up, it'd be positive. So the gradient here is -2. Now the y-intercept doesn't require any work to figure out. It's just where it hits the y-axis, there at 4. So the equation of this line would be y equals mx plus b. How easy is that? Let's look at another example. So this one in 3 is sort of like the opposite to 2. In 2, we had to find m, but we already knew b. In this case, we already know m, and we have to find b. So, first step, find the gradient given to us. It's just 3, easy as. So how do we find b if we don't know it? Well, what you do is you take your equation y equals mx plus b. You substitute the value you found for m. So we just found that m was 3, or we were told it. Now, we substitute x and y, and this comes from the point. So the x value here is -2, y is -3. So I'm going to make those substitutions. Change x. So it's going to be 3 times x, and I'm going to change y to -3. So then I've got the equation -3 equals 3 times -2 plus b. Y equals mx plus b. So let's make this a little easier to handle. 3 times -2 is -6. Now I want to get b by itself. I'm going to add 6 to both sides. I get b equals 3. So therefore, the line would be y equals mx plus b. That would be the equation of the line. So again, there are some special cases, and again, these special cases are lines parallel to the axes. So let's say that I want to find the line parallel to the y-axis, and let's say that it goes through, I'm just going to say -2, 5. Okay, now I can't use the processes here in black. I've got to do something different. I can't find m because this actually has an undefined gradient. Any vertical line has an undefined gradient, so finding m just wouldn't work. What I want to do is sort of the opposite of what I was doing with graphing. When you were graphing, I gave you an equation like y equals 3 or x equals 4. You turned it into a graph. Here, we're starting at the other end and turning it into an equation. So if it's parallel to the y-axis, I know that it's going to be perfectly vertical. I know that the equation of any vertical line has the equation x equals a number. That number just comes from the point there. So it's x equals -2. If I said, parallel to the x-axis that goes through -2, 5, the equation would be y equals 5. I'd get the y value of the point. So these lines that are parallel to the axis, they are slightly different. You can't use these steps here. All right, the last thing I'm going to do on this video, and I'm sorry that it's been a bit long, is I'm just going to go through worded problem. So let's look here at a worded problem. For each delivery, a truck driver paid $20 plus $3 per kilometre travelled, and we're going to find the equation linking A and N. So this is a linear relationship. So $20 he's paid per delivery is a fixed cost. $20 doesn't change per delivery. What is changing is the number of kilometres travelled. That is a variable because it will change from delivery to delivery. So we have that the amount paid will be $20 plus $3 per kilometre. We've just rewritten these words into a mathematical equation. So that part of it was easy. So how much will he be paid for a delivery 15 kilometres away? Well, N is the number of kilometres. So it's just saying what will A, the amount paid, be if N equals 15. So all we have to do is take our equation and change N to 15. So it's 3 times 15. So 20 plus 3 times 15 is $65. All right, how easy is that? So now we're going to look at whether he would be better off just earning $3.80 per kilometre travelled for this very delivery. So if he just earned $3.80 per kilometre travelled, the equation linking A and N would just be the amount. So again, we're just putting the words into a mathematical equation. And that would just be the amount paid is equal to $3.80 per kilometre. So obviously, if he went for 15 kilometres, as he did in this delivery, the amount he gets paid is just 3.8 times 15, which is $57. So obviously, no, he would not be better off because he'd earn less money. So the final question we'll do, how far would he need to travel in order to earn $100 using the first method of pay, which is this one here, $20 plus $3 per kilometre travelled. So in this case, how far he would need to travel is saying find N. And we're told that A, the amount paid, is 100. So what I do is I take my equation, A equals 20 plus 3N, and I simply change A so it is 100. Now I need to solve for N. So hopefully you remember how to solve equations like this. I need to undo everything that's been done to N in the opposite order to BODMAS. So first thing I need to do is subtract 20 from both sides. So I get 80 equals 3N. Now the way I undo timesing by 3, because 3N means 3 times N, way I undo timesing is dividing. So I divide each side by 3. Now the answer I get isn't a whole number. I get N equals 26 and 2/3, or 26.6 recurring kilometres. Okay, it didn't tell us in the original equation whether he gets paid only for a whole number of kilometres. Doesn't matter, we just leave our answer like this. So if he travels 26 and 2/3 kilometres, he will get paid $100. So it's important that you're able to use the knowledge we've gained from linear relations to solve real-world problems that involve linear relationships. All right, I'm sorry, I know this has been a long video. Please ask if you have any questions. Best of luck in the test. This has been the luckiest maths teacher in the world. Have a great day.